Hello guys, what's up and welcome back to my channel, The World of Knowledge with Isham, and today we're going to discuss about Bohr's atomic model. So, let's get into it. So in my previous video, I talked about Rutherford's atomic model, its defects, conclusion, and more other things. If you haven't watched my previous video, I'll just give a link in the description below. Now, an English scientist named Neil Bohr came up on the platform and decided to take action to correct those defects, and thus he came up with the atomic theory, which is today's lecture. He proved that the atom contains a line spectrum by making a series of complications and many other things. The most important thing of his atomic theory is that he used Planck's quantum theory instead of using the electromagnetic theory, which Rutherford used. So let's divide our lecture into two parts. Part number one is model, and part number two is its defects. Obviously, every experiment, every atomic theory has its defects because it is not a principle yet. Well, let's leave the concept of principles and theories for our next biology class. Part number one, model. So, according to Neil Bohr's atomic theory, an electron revolves around the nucleus in definite energy level or shells. They revolve around circular orbits. He also said that as long as an electron remains in the same shell, you can see the diagram of an atom according to his perspective, that when an electron stays at the same orbit, it does not emit or release energy. It remains at the same energy. So according to this, we can already conclude that if the atom does not change its energy while remaining on the same orbit, then it must mean that when it jumps onto the next shell, then it means that it must emit or release energy. And that is why Bohr's atomic theory was one of the most successful theories, even more successful than Rutherford's, Then, as I said, he used Planck's quantum theory. According to that, the angular momentum mvr, let's name that mvr, of an electron is equal to nh over 2 pi, which is basically Planck's quantum theory. The h is the Planck's constant, keep that in mind. Now he also said that the angular momentum of an orbit depends upon its quantum number. Let's leave Planck's, we will talk about Planck's quantum theory afterwards, in the next lecture. The quantum number in which the angular momentum depends is actually an integral multiple of the factor h over 2 pi. As you know, pi is equal to 22 over 7. If you write pi on your calculator, it will give a series of numbers, and you can see the equation. Before we continue on our remaining video, well, give a like on this video because Mr. Subtitle is doing very good for us. You're welcome. The equation you're seeing right now is the NUC is the number of shells. Now, number of shells can be type of unlimited, but it depends on the element. Another time, I guess. So, moving on to our next part of the video, the defects of Bohr's atomic model. As I said earlier, every theory, every model in the early ages had its defects because there were no accurate machines. They did not have any specific or special equipment so that they could, you know, dive deeper into the electrons and protons. They just made a theory that it can be like this, it can be like that. In my previous video, I said that I will tell you about continuous and line spectrum. Now, continuous spectrum is first let's talk about spectrum. A spectrum means that when a light ray passes through a prism, it scatters into different colors. The rainbows. But we are taking this kind of study into a much deeper level. So they have divided a spectrum into two, continuous and line. So continuous spectrum is that spectrum in which colors cannot be seen, that where it starts and where does it ends. So now talking about the line spectrum. Now in the line spectrum, it's actually the opposite. You can determine that if there's a blue line passing and the red one is in front of that blue line, you can simply determine the start and end point of the blue line and the start and end point of the red line, meaning that it can be differentiated. The colors can be differentiated. So that is the only difference between continuous and line spectra. So, quiz. So here's a question coming up. If you have listened to my lectures, questions should be added in there. So tell me that which spectrum does an atom gives? Option A, continuous spectrum, or option B, line spectrum? Just leave that answer in the comments below. I will check it. So what are actually the defects of Bohr's atomic theory? Number one, it cannot explain the spectrums of other polyatomic. We are just discussing hydrogen or other ions which have only one electron. Now, the Bohr's atomic theory does not give the spectrum of atoms that contain multi-electrons. We can also call them as poly-electrons. So that was the whole reason that it was also neglected, as I said, in 1913, just 3 years after Rutherford's big discovery. Point number 2, when a spectrum is seen through a highly powered spectrometer, for example, or we are seeing through a spectrometer, very highly powered spectrometer, and we are observing the spectrum of hydrogen, what we see is that those spectral lines are replaced by few or many several lines. So Bohr did not explain these several fine lines. Point number 3, as I said earlier in our model, that electron revolves in circular orbits. No, it revolves in a third dimensional space. You can say it as 3D, which is 3-dimensional. Now, there's also also the reason of Zeeman and Stark's effect. So after all these defects, we can conclude that Bohr's picture of an atom, which you can again see, was not satisfactory. It did not satisfy all the scientists. And in Bohr's atom, the electrons are moving in orbits with specific velocities, in specific radii, meaning in specific shell, the n value. But according to the uncertainty principle, which is from physics, it means that it is not the entire truth, and the exact velocity and position of an electron cannot be measured. Now, these all were the defects There are also much things Bohr described, and there are also much things that Bohr did not describe. And by saying this, let's end our video, and thanks for watching this video. Do subscribe to my channel, leave a like, and answer the quiz question that I gave to you today in the comments. And if you have any more questions, you can ask me. So also make sure that you have hit that subscribe button, and bye bye.